Okay, so what we're doing is rotations, alright? So like with reflections, there's two things we can look at. We need to look at something called rotational symmetry, alright? That's one thing we've got to consider. And we've actually got to be able to draw the rotation of a shape. So actually that's two different things, alright, but both using this rotation thing, alright. Now, what we'll start with is this rotational symmetry, alright. So we're going to start with rotational symmetry. We're looking at shapes, so we've got three shapes here. Now obviously you've got your solutions underneath, but you're not going to look at them. So it says, state the order of rotational symmetry. So quite often in a question it will say, what's the order of rotational symmetry of this shape? So what we say is, if you want to write notes, if I rotate the shape 360 degrees, how many times will it not look like it has moved?
4.
Okay, so what we mean is when you turn something, if I kind of asked you to close your eyes and I did a rotation and then said, right, open your eyes, has this shape been turned? If you say no, or you don't know, you can't tell, then that would count as having an order of rotational symmetry. Do you understand what I mean?
Mr. Paul?
Yeah.
Like, I know the correct answer is 4 for the first one, but if you return only 1, it would also still look the same. So would that count? Or
Well, the thing is, what we've got to do, we've got to remember that it must be a full 360 degrees. So like you said, this one here, I've drawn a point there so I know where it goes. Now this is, what shape is this?
a square.
It's a square. So if I rotate this square and this dot ends up on that corner, apart from the dot, would you know it rotated? No. So what we would say, that would be the first order of rotational symmetry. Then, so I'm going to put a round empty dot. Then if I sent it to there, that's a second one because it would look exactly the same. Then it would end up here. That's a third one. And then it would end up back. Okay? So this shape has 4. Now, one thing you might say then is every shape has order 1 rotational symmetry. Do you know why?
What does order 1 rotation?
1 order of rotation. So this has got 4. Every shape, any shape at all, has at least 1.
No.
Well, I'm telling you it does.
Oh.
So you obviously don't understand why.
No, but I mean, maybe. Oh yeah.
Have fun. Go on. Yes. Well, you say when it's finished, it's 360 degrees. That's the first. If it's the first time it looks like it's rotated, that's still 1, isn't it? All right. So this shape. What shape have we got here? A rectangle. Right, so what I'm going to do is I'm going to put a dot here. Alright, so just remember there is no actual dot on the diagram, it's just a dot to help me think. So if I rotate this shape, when would it look exactly the same as it does now?
4.
I think 4. So if I rotate this dot, where would it end up?
Well, you go 1, 2, 3,
but
4.
will it go there? Will it ever go there?
Oh
I'm wondering whether, let me just check something. I'm going to open up a new thing. New project. Right, so have you ever done this? Insert. This is quite a good program. Well, have you ever done this? Yeah. Alright, here you go then, Sophie. Here's a rectangle. What I say is, if I rotate this shape, can you tell it's been rotated?
No.
Why not?
Oh, I thought it started like that.
Alright, okay, so we start from here. I'm going to rotate this 360 degrees. You tell me when it doesn't look like it's been rotated from this point. Okay, so I'm going to rotate. Does it look like it's rotated now?
Yes.
Okay.
Yes.
So,
Yes. Stop.
Okay, so my green handle is the thing. So actually, I've got how far round?
360.
I haven't yet.
Mm-hmm.
So I was there. So I've gone
90.
round.
No,
How far is that? 180. So that's the first order of rotational symmetry. Then I keep going round, and I get back to the beginning. So this shape here has 2. Good.
So you always have to keep in mind 360.
Always have to mind the 360.
So that's why I always get confused.
Okay. So, what's going on there? I'm on the wrong thing. Where is it?
Is it filming that?
Yeah. Okay, so this one has how many did we say? 2. Because this dot, the first time it looks the same is actually when it's around here, isn't it? So it goes all the way around. It never stops at that point. So that's 180, and then it goes back again.
The way I was thinking that the dot was moving.
Yeah, you just think the dot's moving around the shape, don't you? Which doesn't happen. This shape then, what do you think? So if I put a dot there, for instance.
2.
You think 2, do you? So that you think after 180 degrees, it will look exactly the same as it does there.
Well, 180 is just the other way, so that would be 1.
But would you be able to tell it looked?
Yeah.
Would it look different?
Yeah.
Why?
When? It would be upside down.
It would be upside down, and you could tell. Now, here's the thing with a rectangle. Do you remember with the rectangle? Is that the right way up or upside down, Sophie?
The right way.
You sure?
Mm-hmm.
Is it the right way up? Or is it upside down?
It's on its side.
So is it the right way up or is it upside down?
Well, it depends if you start like that or like that.
Can you tell?
No.
No. And there's the thing. So if I go back to this one, alright, will you be able to see that it's upside down?
Yes.
Why?
Because the top will be at the bottom.
Exactly. So the only time it will ever look exactly like it does there now is when you've done the full 360. So it must have what order of rotation symmetry? 1. Okay, so it's got 1 because this point will have to rotate all the way round before it looks the same. So just to show you, if I were to redraw it, if it had been rotated...
on how many sides the shape has.
Actually, no.
But then why would the square be 4 times?
Because... So that would look like that, wouldn't it? Upside down, you could tell. If I go back to the word... Right, I'm going to make this a square. Okay. Tell me when it looks like a square like it started. So it's 1, 2, 3,
oh, okay,
4.
I'm sorry, I'm stupid.
You get the idea now, yeah? But as soon as I turn it into a rectangle, it's only 1, 2.
Oh, okay.
You get the difference. And if it's, maybe I can do a different shape. Quite like this. I've never done it with
No, you haven't?
before. I haven't done it with
It's a lot of shapes.
Yeah. So what if I have an arrow?
And you can change the color and stuff.
Yeah, but
And you can
for what order of rotational symmetry is this arrow? Because go round,
like
round.
that you would notice.
Yeah, exactly. You'd notice until
it's down again.
Okay. And it's actually quite obvious. What about some other shapes then?
What about smart art next to it?
Smart art?
Yeah.
Oh, but that's for putting text in. I only need...
Oh.
Right, what about this one? This is a good one. This shape here. If I do that, what order of rotational symmetry would it be?
Yeah, 2.
2 again, because we go, ooh, no, a little different. 1
and 2.
2. Okay. Oh, yeah, we get the idea.
Crazy.
Can't control it. So 2. How could I change it so that it's got 4?
Oh, make them all the same. Make all the sides the same.
If I do that, then it's
4.
So it would be
like that. It looks the same.
1, 2,
3,
3,
4.
4.
So it does kind of depend on the side.
Yeah, actually, no. I mean, I was being a little bit unfair because it does depend. Will there ever be any more than order 4?
No.
No.
Well, yes.
Like you just said, depends on the shape, doesn't it? Let's have a look at a shape.
There can be shapes
what about this one?
Oh yeah, because that's all equal sides. So no, it's not. No.
Depends how I've drawn it. I think I've drawn it right. So what would it be?
So it would be.
So.
Well, it depends. Well,
the way I've drawn
it fairly, then it would
if I've drawn it, this one is actually 1.
5.
Well, no, because you notice that if I rotate it, it never looks exactly the same.
Oh, I thought you were going for it.
Yeah, no, I kind of was, really. So I would have to...
Well, we can just imagine.
Alright, so it'd be good. If it was each side was exactly the same length, it would be order 5.
5.
5. So it's got 1, 2, 3, 4. Exactly. Okay.
Oh, an equilateral triangle would have 3.
Yeah, good point. Let's have a look. Can we find
the smiley face? Oh, what about the heart? Would the heart be heart?
So, what about that triangle?
Isosceles.
So, what order? 2?
1.
Why 1?
Because there's only one time where it can look the same before doing the 360.
Yeah, so it's like...
Before ending.
It's like the arrow, isn't it? Because it would look...
like that.
Yeah, like that's not right. Only back there.
Yeah.
But if I were to, if I can make it equilateral, imagine it's equilateral, it would be
1.
Not working, but you get the idea. 1,
2, 3.
2, 3.
What about a heart? Can we try a heart?
Okay.
A heart would be hard, no?
Well, no, the order of rotational symmetry would be easy, wouldn't it, for a heart?
A heart is next to a smiley. Yeah, heart would be 1.
Yeah, exactly. It would be 1, because it would just be...
like that? 1.
1. Okay, the one I did want to see was, what about this one? This is quite a common one.
Are we looking at the dot or at the line?
So you're looking at that shape. When will it look exactly the same? So... once. Twice.
Well, it would actually depend. If the circle and side were bigger, then it would have to take longer to get around.
It doesn't matter about length. Does it look the same? Do you remember, you're not supposed to see what happens in between. So it's like, if I said to you, close your eyes, so do it now, close your eyes, close them tight, right? Open them. Have I rotated that shape?
No, I didn't see anything.
Well, you can watch the video to see whether I did. And actually I did. So that's the thing. But if I were to do this, so this is quite a good and important question.
Ooh.
So donut, what order of rotational symmetry does that have?
Sorry, can I just say something?
Yeah.
A weird fact?
Yeah.
Mia says that humans are donuts as we have a continuous hole going through our body.
Yeah. But aren't you like Swiss cheese? Because you actually have lots of holes going all the way through your body. There's lots of them. Your skin's got lots of holes, you've got your nose.
No, but like a continuous hole.
Continuous hole. Yeah, I get it. So what's this one then? Order of rotational symmetry.
Oh, 1,000. Because it always is the same.
Good. And so not 1,000, but...
What? 1, 2, 3.
Yeah, well done, Jaina. Infinite. You can never tell. You can never tell.
Oh, it's actually moving?
It is a little bit.
I never told. I never saw it.
No, because you can't. Because I did it almost perfectly. It was almost perfect. So you get the idea about rotational symmetry. Let me just... I would like to find just one more. Let's see whether there is something.
Ooh, down there. The suns and the stars. Stars and banners.
Good point. That would be a nice one. Nice one. That's of this shape.
Yeah.
It's a good one.
Whoa, there's yellow.
So I think actually, yeah, that's what I need to change. Oh, no.
Whoa! Whoa, did you see that?
Right, what's the order of rotational symmetry?
1. No,
One.
1, 2, 3, 4, 5, 6. If you did it perfectly.
Sure, 6.
1, 2, 3. Sorry, 5.
Should be
1,
1,
2,
2,
3,
3,
4,
5. Yeah.
The yellow thing is to put it in. Can you do the yellow thing? Yeah, can you do like a starfish? That's moving.
Yeah. So you get the idea about these rotational symmetry, yeah?
Yeah.
Cool. That's time.